rewatch it back later. So let's get started. Okay. So chapter 11, practice problems. Let's go all the way up here. And in the last session, I kind of went through and told you guys like which questions you can ignore. If you weren't here, I'll let you know while we're going through it now again. So this first one, we're going to ignore it because it's an epoxide question. We don't care about it. Number 2, however, is pretty important. You should know how to do it. So the first thing I would see is Grignard synthesis, right? And that means we're doing a Grignard reaction. This is our product. And it's asking, what would you choose as the starting material? So he gives you the product and he wants you to find out what makes that product. So let's draw out this product. 2-phenyl, 2-hexanol. So 1, 2, 3, 4, 5, 6. 2-phenyl, and I'm going to do pH for phenyl. We know that pH looks like this. And also on number 2, we have an OH. Oh, yes, my bad. All right, so this is our final product, right? That's what they gave us. And we're working backwards, and we know we're doing a Grignard reaction. So the way I would do this is I see my alcohol, right? I know my alcohol comes from a carbonyl. And we just have to figure out what kind of carbonyl it was. And I know it was a ketone because looking at this, I see 1, 2, 3 unique carbon groups. If my starting material had been an aldehyde, one of these groups would be an H. If my starting material had been an ester or something else with a leaving group, 2 of these would be exactly the same. Since that's not the case, you know you started with a ketone. Does anyone want me to repeat that explanation again? Yes, okay. So I know I started with a ketone because we have 3 unique carbon groups here, right? If I started with something else, let's say an aldehyde, right? So if I started with aldehyde plus Grignard, I would end up with an alcohol like this. So we don't have an R group present. I mean, we don't have an H group present, so we couldn't have started with an aldehyde. If we had an ester as our starting material, and we had the same reagent, we would end up with an alcohol and 2 R groups that are exactly the same. And in the example they gave us, or in the product they gave us, we don't have an H, and we don't have 2 groups that are exactly the same. So that means we had to start with a ketone. And I will leave that up for a moment, and then I will keep going. If we started with an ester, yeah. Anyways, let's get rid of this. Is everyone done writing? Okay, cool. Delete. So he makes it easy for you because he gives you answer choices, right? So you don't have to go through and figure out every possible thing it could be. Instead, I'm just going to draw out these answer choices. So we have 1, 2, 3, 4 carbon chain. 1, 2, 3, 4 with a bromine at the end. Oh, is it lagging? Okay. Damn, it's just lagging. And then we have this. So this group is just a benzene. So I'm just going to call it a phenyl pH because I don't want to draw that every single time. So we're going to go through and just make sure we have all the right pieces, right? So we have this, which will make the alcohol. Cool. We have the methyl, right? We have the 4-carbon chain, is this right here. And last but not least, we do have this phenyl. So do we have all the pieces present? Yes. So could this make the correct final product? Yes. So I'm going to put a little check here. The next set has 1, 2, 3, 4. So that looks like this. And then we have this. So now we have our OH piece, we have our methyl piece, and we have our phenyl piece. But do we have our 4-carbon straight chain piece? No, because this does not look right. This would make a Grignard reagent that looks like this. And if we add that, it will not turn into a straight chain because we cannot do rearrangements. So I'll make a little note. No rearrangements. So this will not work. So I will cross that one out. That's not going to work.
What did you say about rearrangement?
So this carboanion cannot have rearrangements. So we still have 4 carbons, but they're in the wrong formation, I guess. Here we have to get a straight chain. Here we have the branches.
So it cannot rearrange because it's just with that.
Yeah, it's just not allowed. We can think of it that way. Alrighty, for answer choice C, we have 1, 2, 3, 4. Actually, I like to have the carbonyls up. So 1, 2, 3, 4. A methyl on the other side, plus Br. So we have the phenyl group right here. We have the alcohol group right here. We have our methyl. And we also have our straight chain, our 4-carbon straight chain. So do we have all the pieces? Yes. So could this work to give us the final product we want? Yes, it can. So C also checks out. So the correct answer would be A or C. And I'll zoom out so you can see it all together. Yeah, we're basically just looking at which answer choices have all the right pieces. Starting to get it? Yay. Oh. Oh, okay. Cool, cool. And then again, if you guys want to move forward at all, feel free. Okay. We're going to ignore number 3. That's trash. We're going to ignore number 4. That's also trash. We haven't covered that material yet. So that'll be relevant for the next exam. This one we can talk about. So we're going to say nucleophilic addition, carbonyl group. So what this is saying is, let's say we have some kind of carbonyl, right? And let's say we have some nucleophilic addition. What I immediately think of is a reduction reaction. So in a reduction reaction, we know that the reducing species is that hydrogen, right? Or the hydride, you could say. So when that hydride attacks this carbon and these electrons go up, the hydrogen gets added to that carbonyl carbon, right? So we can call this a nucleophilic addition. And again, we call it a nucleophilic addition because anything that uses electrons to attack and attach to another atom, we're going to call that a nucleophile, right? So nitrogen acts like a nucleophile and it adds to the carbon chain. And we know that in the end, this H minus will get protonated and it will turn into an alcohol. So cool. Now we know what a nucleophilic addition is like. And the question that they are asking you is, what is the hybridization change? And we're specifically talking about the carbonyl carbon, which is this carbon right here. So what's the hybridization with the ketone? sp2, exactly. What's the hybridization as an alcohol? sp3, exactly. So A is our correct answer. Yes. So for Roche students, I emailed this to you guys. You don't have access to it on Canvas. I know. So check your email. If you don't have it, shoot me or Katrina an email and we can send it to you. Okay. So I'm just going to really quickly, while we're going through it, I'm going to tell you which ones not to worry about. So number 6, don't worry about it. Number 7, don't worry about it. This one do. This one, don't worry about it. 10, don't worry about it.
Don't worry about 6, 7, 9.
Yes. 11 is fine. 12 is fine. 13, get rid of it. 14 is fine. Get rid of 15.
How do you get this document?
This I emailed to you guys.
What is it?
It should be like a helpful resources or something that I sent you guys as an email. While you're looking for it, I'm just gonna keep going. This one I guess you can keep.
Oh, it's a bunch of documents. It's like practice problems.
Yes, it's the 11 and 12 practice problems. We can keep this one. We can keep this one, I guess. We can keep that one, I guess. We're gonna get rid of 22. We're gonna get rid of 23. We're gonna get rid of 27. We're gonna keep them up until 34. That's literally chapter 13. I don't know why it's here. We're gonna get rid of 38. And yeah, that's it for now. This one, I don't think it'll be on your exam, but they like to bring it up every now and again. So I'm going to cross it out, but I'm also going to give you the answer just so you know. So when we're looking at this kind of chain, right? First thing we need to know is single bonds are the longest, and then double bonds are in the middle, and triple bonds are the shortest. So triple bonds are shorter than double bonds, which are shorter than single bonds. And so if he were to ask you which of the following bonds is the longest, you want to pick the single bond that's as far away as possible from all the rest of the double bonds and triple bonds. So double bond, triple bond. This single bond is the furthest from the rest of these guys. So that one is going to be the correct answer. It's not a super scientific things, just know that like the further you are from a double or triple bond, the longer the single bond will be.
What was the answer?
E. Oh, dang, I thought you guys could see it. Sorry.
What was the thing that you said about the farther?
The farther you are from from the double and triple bonds, the longer the single bond will be. And I can say that again. The farther you are from double and triple bonds, the longer the single bond will be. Okay, you want to do 30. Okay.
Just because she asked about the R's.
Ah, okay. Cool. So let's name this molecule. Yay! I'm going to redraw it because I don't know about you guys, but I hate condensed formula. So 1, 2, 3.
How are you figuring out that? Okay.
What?
No, like I was like, how are you figuring out the chain through when it's like written like that? Because that confused me.
I hate when it's written like that. I literally have to number it and draw it out.
Okay.
So what I always do is I number like the easiest chain. So 1, 2, 3. And then I know that on carbon 3, I have an O. So I have an H, I have a CH3, I have an O. And on the other side of it, the O has a benzene ring because C6H5 is a benzene. And then I also know, or no, that's it. Okay, cool.
Would phenol be the same or no?
So, okay, when it comes to benzene, if it's directly connected like this one is, you're absolutely right. It's called a phenyl. And if it is connected with a CH2 in between, like this, that is a benzyl because it has a little bend in it, benzyl. So in this case, you're totally right. This would be considered a phenyl.
But basically, the C6H5 is basically just a ring, so it's connected to something else.
Yeah, exactly. Cool.
So Roche students don't have to worry about this, or we do?
You do. The only thing Roche students don't have to worry about is mass spec. Wait, you're in Roche's class? Okay. Yeah, so pretty much all of you guys are in Roche's class. You guys are in West's class. Okay. Doesn't really matter, but good to know. Alrighty, so let's, yes. Yep. So the longest chain is going to be 1, 2, 3, 4 carbons, or we could number it 1, 2, 3, 4 carbons. What would you guys choose?
Right. Purple.
Purple, yes, because we want to have the substituent on the smallest number. So we would have a butane ring. Not ring, excuse me, a butane chain. And then on carbon 2, we have an ether substituent. And now it has occurred to me that you won't have to name ethers on your exam.
They had like a list, and on their list it said ether.
Yeah.
Was it on the like reaction roadmap garbage?
No,
Yeah.
he sent an email that said we have to naming alcohols, phenols, and ethers.
And I think
Swag.
Dr. West said it in class too.
All right. Well, in that case, we're going to take a detour. So naming ethers is super straightforward, honestly, in my opinion. So if we have ethers as the main chain, before I do that, I'll go back 1 second. I just want to add a page. Okay, so if we have an ether and the ether is like the parent, like that's the only thing that exists in that molecule, for example, like this, we're literally just going to go left to right Let's say this side is a methyl. This side is an ethyl. What's the functional group?
Oh, ether.
Ether. That's how you name it. So let's say we have, okay, sure. If we have two methyls, we're just going to call it dimethyl ether. Let's say we have something spicy. I don't know. What is the substituent on the left? Phenyl. Yes. I was hoping at least one person would get tripped up. From a loving place. Phenyl, ethyl, ether. No, it's not bad. Okay. The part where it gets bad is when we have them as substituents. So I know someone's going to ask, at what point does it go from being the parent to a substituent, right? Yeah, at what point does the ether go from being like the parent chain to like the substituent, right? Because we have an ethyl, right? For the purposes of this class, if there's a carbon chain with 5 or more carbons, at that point the carbon chain is considered the parent. So I will write that down. So chain with 5 or more carbons will become the parent chain. And this does not include the benzene ring because benzene ring is just like one unit. So if we have a straight chain that's 5 carbons long, that becomes your parent, and the ether becomes a substituent. Someone had a question. I don't remember who it was. Okay, fine. Yeah. Yeah. I too was very curious about this, and then I spent 45 minutes with Dr. West in his office hours looking at 5 different textbooks, and then he went, doesn't matter. And I was like, okay. So, okay, if it's a substituent, this is pretty straightforward, what I have written here, but we're going to name based on the number of carbons that come after the oxygen. So in this case, we have our parent chain, right? That's a pentane. And we have 2 carbons coming off of the oxygen. So we're going to call that a F-oxy. So F for the ethyl, oxy for the ether functional group, and then pentane. Oh, yes, I can. So we're going to use oxy for the ether when it's a substituent. And we're just going to put whatever number of carbons we have before oxy. So, for example, here we have an ethyl chain, so we would call it an S-oxy.
Because it's connected to 2 carbons.
Exactly. So if we had 4 carbons, it would be a butoxy. Cool. And then the rest of the chain is just named a pentane. Pretty straightforward. So I'll zoom out in case you want to take a picture or anything. The last, yeah, what's up?
Oxys because it's connected to oxygen.
Pretty much, yeah. I'm gonna go here for a second because this comes up once in a blue moon, and then students get very upset that I didn't cover it. So if you have 2 double bonded oxygens, so 2 ketones, 2 carboxylic acids, whatever, we're gonna call that oxo.
If we have 2 oxygen.
Yes, so if we have 2 double bonded oxygens, such as here, right, we know that this is priority because carboxylic acids have like the highest priority. So we're going to start counting here. 1, 2, 3, 4, right? And we have a ketone on carbon 3. So how do we kind of like name that ketone? Well, we're just going to call it 3-oxo. And then just name the carboxylic acid. Since it has 4 carbons, it would be butanoic acid.
Why isn't it one oxygen?
Because the ketone is on carbon 3.
But the alcohol is the priority, right?
Well, this isn't an alcohol, it's a carboxylic acid. So this whole thing is one functional group, and that gets priority. So we start counting here. And so the parent chain is this plus these carbons, right? And we're counting this ketone as a substituent. And instead of calling it like a whatever ketone, we're going to say just 3-oxo and then whatever type of acid it is. So this is very specifically for if you have a carboxylic acid and a ketone, or if you have 2 ketones or a ketone and an aldehyde, things like that. But it'll be very obvious. All the answer choices will say oxo, so just put the right number in front of it. Yes, Leah.
So the 3 is because there's 3 oxygens?
No, the 3 is because the ketone is on carbon 3. So this would be carbon number 1. This would be carbon number 2. This is carbon number 3. And we're basically using oxo as a replacement name for the ketone. So we're saying at carbon 3, we have a ketone, and then we have a butanoic acid. Okay. Was that also your question?
Yeah.
Okay. Swaggy. So yeah, I'll zoom all the way out in case anyone wants to take a picture or anything. Ta-da. So the naming ethers, is this okay-ish? Yeah.
The question was about the R or the S. No?
Yes, I know. But I realized that there was like the whole thing with the ether was there, and I was like, we haven't done that yet. So let's go back. Okay. Okay. 10 years later, let's answer this question. So we are looking for R and S. This is the chiral center, so I'm going to give it a little star right there. All right, so based off what we just said in the ether naming, what do we think this ether's name is going to be before we go into RS, whatever? Okay, it could be phenoxybutane.
Oh, wait, no.
Or it could be a sec-butyl, exactly. So we're going to get rid of isobutyl and tert-butyl. Cool, so we're between A, D, and E, right?
What's not over 5?
Exactly, so it's not over 5 carbons. So in this...
So that means it has to be A, right?
Yep.
The answer sheet said it's E. I mean, E.
It says E. Okay, that's why I asked him about it. He said if it's 5 and above, he said disregard that. If it's 5 and above, do that.
I thought his answer said E. All his answers are wrong.
What is sec-butyl? Like, what does sec mean?
Sec just means secondary. So we have a 4 carbon chain, 1, 2, 3, 4. But instead of it being like this, it'll be attached like that, so that it'll be secondary.
Wait, can you explain that again?
Yes. Yes, 1 second. So this is a sec-butyl. This is a tert-butyl. Yep. Because this carbon is going to be attached to 2 carbons. So it's secondary butyl. This carbon is attached to 3 carbons. So it's a tertiary butyl. And then isobutyl is going to be very similar to the sec-butyl, except it'll be like that. Ta-da. All right, so for this question, I'm gonna go ahead and ask Dr. West about it, just because I don't want to give you guys the wrong answer. Very briefly, let me just RNS right quick. I know. I really wanted to avoid doing it. Cool. Alrighty, so let's say we have yes.
Does it matter? Does it matter? Like, alphabetical order? Does that matter? Or
Not really. I mean, I guess it's most correct if it's in alphabetical order, but I just go left to right. You'll get the same answer. Okay, so let's do RNS to this carbon. All right, so the first priority group is going to be the OH because it's an oxygen. Cool. Last place is always hydrogen. Hydrogen sucks. And then this one is a higher priority than this one. So we're going to say this is 2 and this is 3. Alrighty, so I don't know how you guys learned it in Orgo 1, but the way I do it is I just ignore the one that's in the back and I connect them. So 1, 2, 3. This is going clockwise, which is R. And if 1 or 3 is in the back, you would flip it. If 2 or 4 is in the back, you keep it. So this is staying R.
this makes no sense.
I know.
Because the answer key is S. That's why it doesn't make any sense. So it
Well,
wouldn't be-
this is just a completely different thing.
Oh, okay.
This
Okay.
I just made this up.
This makes sense.
Okay, cool.
Oh, it's S too.
Huh?
On S, the answer for S it makes sense. Because O is 1, the CH2 is 2, the methyl is 3, the H is 4.
I am gonna ask
Thank
him.
you, Rosemary.
You're welcome. Please sign out.
Right over there, right?
Yeah.
Okay.
All right, so I am 100% gonna ask Dr. West about this one because I don't know if he just hasn't changed the rule.
Are you talking?
Or what?
Are you gonna ask him about naming issues too?
Yeah, just because for this example specifically, the rule is supposed to be that 5 or more, so it would stay that kind of naming. But he's saying that the parent chain is the 4-carbon ring, which is not what he told me. So I will double check that one.
Can you do an example where it's backwards? You see what this
Yeah, sure. So
Let me know when it gets to 5%.
So let's say we have the same substituents. 1, 2, 3, 4. So we are going to ignore the one that's in the back. Right? And yeah.
Oh, because we're doing the front.
Yeah, so whenever we do RNS, I just ignore the one that's in the back. And we're going to connect the rest of them. So it'll be 2, 3, 4. So that's counterclockwise.
And
No, it's not. It's clockwise.
why did you start with 1 as the OH in the back? Just because I have to remember this stuff.
Okay, so the OH, I just put it in the back just because that's the molecule I picked, right? And the reason I count it as number 1 is because oxygen has the highest mass out of these guys, so it's a priority. Bye, Leah. Yes.
They'll have to flip though, right?
Yes, exactly. So since number 1 is in the back, we're gonna flip it to S. R to S. So that's the difference between if you had 2 or 4 in the back versus if you had 1 or 3 in the back. Yes.
Okay, if you do the spiral setup for the problem, because I don't know how I can, like, I don't know if I can still see it.
For this question, I don't want to do this question anymore because I don't want to keep giving you the wrong answer. So I want to know what Dr. West wants from it. But we can do another RNS question if you want.
Repeat what the goals are for the RNS with the numbers. Like,
Yes.
Number 8 first.
Yeah.
1 moment. Okay. I got multiple requests at once and my brain turned off. So I'm going to explain this one more time and then you ask me what question you want me to do. So for RNS rules, we are going to number the priorities, just 1 through 4. And then we are going to ignore whichever one is dashed. So whichever one is in the back. And we're going to connect the other 3 groups in number order.
Can you repeat that?
Yes.
I'm sorry.
So we are going to number all of the substituents, and then we are going to ignore the one that's in the back. We're going to pretend it's not there, and we're going to connect 2, 3, and 4 in number order. So either you'll connect it clockwise or counterclockwise. Yes.
Just to confirm, dashed is in the back, right?
Dashed is in the back, yes.
Yeah.
So then once you draw clockwise or counterclockwise, if you have substituent number 1 or 3 in the back, you're going to flip your final answer. So here we got R, but number 1 was in the back, so we flipped it to S. If 2 or 4 is in the back, you leave it whatever you have. You leave it as whatever you have.
You got it.
Okay.
It was there somewhere from more than one.
Yeah, it was there somewhere. It's just deeply repressed because Orga won.
Yeah.
I took it forever ago. I don't know what's happening in that class. Okay. Any other questions about this before we put it under the rug and ignore it forever? Okay, swag. So number 8. Yeah, I like that too. Who destroyed it? Okay. Yes.
Is there any way you can go through the ones that we don't care about through like this one certain thing? Because I know you did it earlier.
Yes. Also, I have decided to make an executive decision because I don't want to do it again. I'm just going to send you this packet with the X's. Okay. So I was like, wow, why did someone say something in the chat? I've been ignoring them for so long, but it's me. I'm the only one in this. So anyway, okay. So the IUPAC name for this one, I have to redraw it because I can't see it. So right now I'm just going to give arbitrary numbers. I'm going to 8. So I'm just going to say 1, 2, 3, 4, 5. Again, that's just arbitrary numbering, so I know what I'm doing. 1, 2, 3, 4, 5. Cool. So on carbon, what I called 2, I have an OH and a hydrogen. And on carbon, what I called 4, I have an ethyl. So now I'm going to erase these numbers because those didn't really mean anything. And now we're going to figure out who is the longest chain. So could you chill, bro? Thank you. Just like slipping and sliding. Okay, so we could do 1, 2, 3, 4, 5, 6. Or we could do 1, 2, 3, 4, 5, 6. Which one do we like better? We like the red one, yeah. Okay, cool. So 6-membered is a hexane. On carbon number 4, we have a methyl. On carbon number 2, we have an alcohol. So we're just going to put those pieces together to get 4-methyl. And there's actually 2 ways we can write this. So I'm going to do it the most correct IUPAC way. 4-methyl hex and 2 all. Oh, you can't even see that. Ta-da. Or you could write 4-methyl 2-hexanol. Either one, both of those would be equally correct. He can't give you both of those and make you pick an answer. It just depends on the day. He'll give you one or the other.
Are his tests multiple choice?
Yes, they're all gonna be multiple choice. They're always mad. The professors. No, Dr. West is just very chill to a point where it like makes me distraught. And then Dr. Roche is just an alien made of anger.
You don't have
Yes.
to worry about that. Like adding 2 answers that's correct.
No, so you will have either or. You won't have both of those because both of those are correct.
Would it be like, okay, so you know what Saint Germain, he would put like an answer that like could be right if you skip this step. Would it be like that?
So like he would have it the other way, like numbered the other way. So it would be 3 methyl, 6 or 5 all kind of thing. But you know, it won't be like, or he'll give you like 4 methyl, 2 pentanol, right? But it's not going to be like anything worse than that. Okay. So someone actually reminded me about the recording. Let's see how long this is. Okay, we'll stop it there. We're gonna do in order. We're just gonna start at 11 because we did number 2 already, or we did the first couple already. So
you guys did like 1 and 2 and stuff?
no, we're not doing number 1. We did number 2, and then we skipped a whole bunch.
Yeah, I'm just making sure.
Okay, so for this one, it's asking you about resonance structures. So resonance is just the movement of electrons, right? So in this first one, you can move the double bond and get that structure, right? You move the double bond and you move the plus charge. For the second one, you're going to move the radical and the double bond to make a new double bond and a new radical. For the third one, again, we're just going to flip the double bond over here, and the positive moves from the CH2 into the ring.
Wait, can you explain the second one again?
Yeah, so we're going to have 1 electron from the radical go here, and 1 electron from the double bond go here. And so that ends up making 2 electrons for the double bond, and that leaves 1 electron here to be a radical. And then the last one looks exactly like the one before it, except now there's no double bond. So it's just randomly picking up a charge and moving it. That's not resonance. So that does not represent a pair of resonance structures. Help.
When looking at an NMR chart, the right-hand part of the chart is the.
So when you're looking at NMR, this side is de-shielded and downfield. This side is shielded and upfield. You sound very stressed out. And nothing good comes from anxiety. So we're going to ignore this one. Number 12, we're going to ignore that one. 13 we're ignoring. 14 we can do. So also, just to give you guys some, like, I guess, hope. When I took this class, I was scared out of my mind. I did not remember anything from Orgo 1. Orgo 1 was a blur. I literally had a panic attack in the middle of my exam and cried my eyes out. But here I am. So, like, you know, the anxiety thing, like, I've been there. I wasn't, because people assume that, like, when you're the tutor, you just were, like, so smart and, like, you just knew everything. Absolutely not. Orgo 2 is one of those classes where you can, like, figure it out, and then you can, like, get by, and then it makes sense later. So, you got this.
Question, are we doing 12 or
No, we're not going to do 12.
no? Like we don't even know that one?
No. That one is about epoxides and stuff. So for 14, we see mesylate, and so we know that's a protecting group. protecting group question. And we know that mesylate is basically going to take, hold on, I'm trying to figure out where to write this. There we go. Mesylate and tosylate are going to take this OH and they're going to basically grab the O and attach it to the mesylate group, like so. Excuse me. And that is going to keep the stereochemistry exactly the same. So this second step of the reaction, I'll actually do it a different color. Do red. So NaI is what they're giving you. So NaI, NaOH, NaBr, all of those things are going to be SN2 reactions that are going to replace the oxygen with either an I or an OH or a Br. And in SN2 reactions, we flip stereochem. So you have those two pieces of the puzzle. Let's put them together. So in this example, we're working with mesylate. So in this first step, we're going to keep stereochem. And in the second step, we're going to flip and we're going to replace the O with an iodine.
I'm just here to say hi to again.
That was good, Chris.
That's my guy.
Hi.
What's going on? How about you? You know, just taking the quiz on the phone.
Been here since 7:45.
I said hi.
Thank you, man. Appreciate it. It's nice seeing you.
And that was recorded.
What a guy.
What an ogre. This is why I call him an ogre, dude.
Someone kept saying in the chat, "Come claim his swab." What the frick is wrong?
That killed me. That killed me. Okay, so someone was like, I think it was Daniel, was like, he said like, I love you, Daniel. And Daniel, I was like, I have to edit stuff out. And he's like, can you keep the part where he said, I love you, Daniel? And I was like, I don't know, we'll see how it goes.
Yeah, that man's got a weird love relationship for Chris. I'm like, bro. He's like, he helped me pass the workout. I love that man. I'm like, okay,
That's fair.
fair enough.
Some people just take it to the extreme, and as long as you're not creepy about it, it's fine. As long as they're not like stalking you, which just happened. Anyway, all right. So for this one, we're looking for the answer. First of all, that does not change this group. This group is going to stay exactly the same. So this one is good. It stays the same. Good. Flipped it around. No, awful. We hate that. This one's good. Hello. Alrighty, so between those three, we're looking for the one that replaced OH with an I and flipped it to dashed. This one, what the heck is that? That's not an I. Garbage.
Wait,
Absolute trash.
You're looking for I?
Yes, so this last one, OSO2 or blah, blah, blah. Ew, trash, garbage.
How come I'm looking for an I?
Because we have NAI as the last step. So,
Oh, it's an I.
yeah, that's just, that, you can't really tell, but
I
that's,
thought it was a null.
no, it says NAI.
Okay.
Supposedly.
Wait, did it do the inversion?
It's going to do an inversion, yes. So you want the answer that did an inversion, which is this one. So the correct answer is number 2.
Okay, so and it's a mesylate. So basically, you just switch the OH to Cl, right? That's the first step.
Yeah.
and then you bring like an acid, and then the acid does the inversion, correct? Or
It's not an acid, it's a nucleophile.
I mean a nucleophile.
Yeah, and that's going to do the inversion. Yep.
All right, then what's the difference between that and then like you doing it with you doing it with a protecting group without like the mesylate? Does it just go all the way through?
Well, mesylate is the protecting group. So we have two different protecting groups. We have mesylates, which is what we just talked about, and then we have PBr3. PBr3 turns an alcohol into a halogen, and it's SN2, so it flips.
So it doesn't need a second step.
Well, if you're just doing the PBr3, it will stay a bromine. If you want to turn this back into an alcohol, you can react it with the same kind of thing, NaOH. That'll be SN2 again, and it'll flip it back into an alcohol. So we're looking for a tosylate, and we know that tosylate has an S double bonded to two oxygens. So if you know nothing else, you can see, haha, this one sucks.
The last one.
This one sucks. Because they don't have two double bonds, so those suck. So now you have 1/3. Your odds are much better, right? You also know that tosylate, because I'm telling you so. So you want to have a benzene with a methyl on it. So this is a bromine. We get rid of the bromine. It has to be the first one.
So it's